So welcome back on the day 10, and today what we're going to be doing is shell sort algorithm. So as always, we're going to do the first theoreticals and then we'll slowly move towards the practical. So the first thing is definition, then advantages and also the steps. So let's just start first with the definition of shell sort algorithm. So shell sort improves upon insertion sort by breaking the original array into tiny subarrays, and then it starts to sort them, and then as they are sorted it reduces the gap gradually until they become a single big array like the total original array. Only the doing is a little bit different in this case because it creates the gap and then reduces the gap gradually, but the sorting is done based on the insertion sort only. By using the regular insertion sort, the only difference in this particular algorithm is that it creates the gaps and then reduces the gap gradually. So that's how it works. So once you understand the definition, let's move on to the steps and see how it is performed. So step 1, choose the initial gap, and then step 2, sort subarrays. Step 3 is reduce the gap and find the insertion sort. So let's just understand each of those steps a little bit briefly. So the first one is choose an initial gap. Start with a large gap value, often half of the array length, and just reduce it over iterations. That's how the game works. Then sort subarrays. For each gap, sort the subarray created by the element that a gap position apart from insertion sort. That's it. Then what you do is reduce the gap, gradually reduce the gap. Typically you can use like gap divide by 2 or something like that, and until it becomes 1. Until it becomes 1, you have to just reduce until the entire array is just totally original. There is just one list, there is just one array. Then the fourth step is find final insertion sort. Performs the final insertion sort when the gap is 1, ensuring the entire array is perfectly sorted. So this is basically the steps of performing the shell sort algorithm. So let's not waste our time on any of the nonsense and just do the coding and see how does this actually works. So the first thing you do is just to create a function, and then what you do is just to save the length of the array, right? All right, let me do that real quick. Side n, and then you initialize the gap. All right, so once you're done with that, all you have to do is just create a while loop and perform insertion sort for this gap size, this particular gap size. Okay, it's going pretty well. And once you're done with this step, you have to shift earlier the gap sorted elements until the current location of array 1 is final. Okay, then you just create one more loop, and once you're done with like j minus this, an array of j is equal to temp, all you have to do is just reduce the gap size. Now once you're done with sorting the elements in the minor arrays, all you have to do is just reduce the gap, right? Once you're done with reducing the gap, it will go until it becomes 1, and so once it becomes 1, that's it, done. So just create the array and do the sorting and print the array. That's it. And if I were to run this, I'll be getting a perfect output. All right, say 10 and run this program real quick, and you can see the first array and the second array is okay. There is some kind of mistake. I think we have fucked up somewhere. Kind of like I guess up here it was supposed to be I, not 1, and I think it's gonna be perfectly fine, and it is perfectly fine. So here our shell sort ends. So here all of our sorting algorithms are done. Now we'll move to searching algorithms from tomorrow. See you then and there.